The world might have turned its eyes toward the Arctic for its mineral potential and its role in global shipping. We're realizing this new frontier is far more volatile than our maps suggest. In September 2023, monitoring stations across the globe detected a seismic signal that baffled the scientific community. It wasn't the sudden snap of a tectonic plate or the rumble of a standard earthquake. It was a monochromatic vibration, a single, steady hum that lasted for 9 straight days. Tracing that signal led researchers away from known fault lines to a remote, uninhabited waterway in East Greenland, Dickson Fjord. What they discovered wasn't just a localized accident, it was a symptom of a massive structural transition. This is a transition that challenges our ability to inhabit or even monitor the changing north. To understand why this happened, you have to understand the unique architecture of Greenland's coast. The island is largely defined by its ice sheet, a frozen mass of up to 3 kilometers thick, which meets the ocean through a network of steep, parallel-sided fjords. In Dickson Fjord, the scale is hard to comprehend. Mountain peaks tower 1,200 meters above the water, while the channel floor plunges 500 meters below the surface. For millennia, these mountain walls were held in place by glaciers at their base. That's a natural buttressing system. But as the climate warms, that physical support is thinning out. Essentially, the retaining walls of these fjords are being removed. In most parts of the world, a landslide ends when the rock hits the ground, but in the confined vertical geometry of a fjord, the energy has nowhere to go. It becomes trapped. We've seen the human cost of this instability before. In 2017, a rock avalanche in West Greenland's Karrat Fjord triggered a tsunami that destroyed 2 villages, and guess what? Well, that made them permanently abandon these affected areas. It was a stark reminder that in the north, geography is destiny. But the 2023 event at Dickson Fjord demonstrated a scale of dynamics we simply hadn't seen. 25 million cubic meters of rock, the equivalent volume of 25 Empire State Buildings, sheared off a peak and collapsed into the sea. The result was a 200-meter tall mega-tsunami. Because the fjord is so narrow, the water began to slosh back and forth every 90 seconds, creating an oscillating standing wave known as a seiche. For 9 days straight, this immense rhythmic transfer of energy pounded into the Earth's crust, sending that mysterious signal around the planet. It was, quite literally, the Earth ringing like a bell. While Dickson Fjord is remote, its reach was not. The surge traveled 72 kilometers outward to Ella Island, striking the Nanook research base. And while no lives were lost this time, the infrastructure was decimated. And this is where the concern lies for the future of the Arctic. As Greenland becomes a focal point for mineral exploration and geopolitical strategy, our human footprint in the region is expanding. We're building mines, research stations, and shipping routes in a landscape that is losing its structural integrity. When you combine spotty satellite coverage with emergency response times that can exceed several hours or even days, a breakdown in these conditions quickly becomes life-threatening. The 9-day signal of 2023 wasn't just a geological anomaly, it was a direct measurement of a destabilizing Earth. As we look to the Arctic to sustain our global transition, whether through rare earth minerals or new trade routes, we have to ask if we're prepared for the reality of the terrain. Understanding the mechanics of these fjords is no longer a matter of scientific curiosity. It's a fundamental requirement for the safety of anyone calling this frontier home. The Arctic is changing, and it's moving faster than our infrastructure can keep up. But what do you think? As we push further into these remote regions, how should we adapt our approach to a geography that is quite literally falling apart? Let's discuss it in the comments below. And as always, if you enjoyed this look into the systems that shape our world, remember to like and subscribe. This is Geo Blueprint, and I'll catch you in the next one. Peace.